All right, the last type of problem we're going to work with the half-angle identities is a identity verification, another proof, essentially a two-column proof. Again, with these sorts of problems, we're not sure whether or not the equation is true necessarily, so I don't know that this is true until I prove it, until I verify it. So we're going to use the two-column proof idea. Again, we could work on one side and end up at the other, or we could work on the other side and end up at the first, or we could work on both and end up with a shared expression at the end. I see right away there's a sine squared of x over 2. This thing, I'm not sure what it's going to be. I'm not sure how I could really simplify that yet. But the sine squared, I know immediately what the formula is for the sine of x over 2. So we could work with that side first. I think that'll be a little bit easier. So let's do that. So we're going to start with the sine squared of x over 2. Using our half-angle identity, I know that that's essentially, you're squaring the sine. So you're taking the plus or minus square root of 1 minus cosine x all over 2, and we're squaring it, okay? So that's a half-angle identity. Okay. Now, when you square, whether it's positive or negative, it's always going to be positive after you square it, right? So we don't have to worry about that. The plus or minus kind of drop out with the square. So does the square root, okay? We do have to assume this thing to be positive. Right, so if I just, the square root of a square, or the square of a square root, really gives you an absolute value, unless the stuff underneath is positive, then you can just cancel them out. And this stuff underneath is going to be positive because the cosine, remember, cosines are always between -1 and 1. They're always less than 1. And if you subtract something less than 1 from 1, you get a positive value. When you divide by 2, you get a positive value. So we can't really have an undefined root here. So it's going to be okay to cancel out the square root with the square here. So essentially what we get is 1 minus the cosine of x all over 2, and that's just by canceling the square root and square. Or simplifying, maybe that's even better. It's not really canceling, we'll say simplifying. Simplifying the square root and square. Okay, that's better. Then we take this expression, and I'm going to compare it to what we're looking for. Right away I notice what we're looking for has a difference on top. What I have here has a difference on top, so there's some similarity already. What I have is a 2 on the bottom. What I'm looking for has a 2 on the bottom. What I notice is that there's this extra tangent on the bottom and a tangent on top, and there's a sine in place of a cosine. Well, let's just try to work toward this as a goal. How would I get a tangent on the bottom in addition to the 2? Well, to answer that question, all you'd have to do is multiply the bottom by a tangent, right? But I can't just do that. I have to do whatever I do to the bottom, I'd have to do to the top if I'm multiplying. So, with a fraction. So what I'm going to do is multiply the bottom by the tangent of x and the top by a tangent of x. Okay? Multiplying the top and bottom by tangent. So I'd have 1 minus the cosine of x all times the tangent of x all over 2 times the tangent of x. Okay, so all I've done is I've multiplied by technically just 1, right? It's 1, which is equal to tan x over tan x. Multiply top and bottom by tangent, which just is 1. Okay, so now if I distribute the tangent on top into the parentheses, we're going to get, I'm going to take this off to the other side here. we're going to get a tangent of x minus tangent times the cosine all over 2 tangent of x. So that's a distributive property. Okay, and now you're going to see that this expression I have is very similar to the one that we're looking for. I've got the tangent, I've got another term, I've got the 2 tangent on the bottom. If I simplify the tangent times the cosine using a quotient identity, the tangent is sine over cosine, right? So if I replace the tangent with sine over cosine, and then multiply by a cosine. But first of all, that's done using a quotient identity. I should write that down. Well, then the 2 cosines here will cancel, right? One on top, one on the bottom. So I can cancel the cosines, and I'll be left with tangent x minus the sine all over 2 tan x. And that's done simply by reducing the fraction. Okay? That happens to match up with what we have on the other side, and so our proof is done. This is a verified identity now.